Hey class, this is Miss Birchfield. This lesson is on section 3.4, linear and angular speed. I'm going to kind of run through this pretty fast with not explaining much. Really all you need to know is in this section you're going to find the linear speed. The linear speed is how fast this point on the circle is going around the circle. And we can find that using this formula, which is velocity equals s over t, where s, remember, is the arc length from 3.2 and t is time. We can also find the angular speed, which the angular speed is how fast the angle is changing around the circle. And we can find the angular speed using this formula here, which is, that is a lowercase letter for the omega. So it's omega equals theta over t, where omega is the angular speed, equals theta is your angle, and remember your angle has to be in radians, over time. Now we do have a few versions of linear speeds. This one, v equals s over t, was the one from the previous slide, but we can also substitute in for v equals r theta over t. If you remember from the previous section, the s equals r theta, which was the arc length. We could say that instead of s here, we can substitute r theta over t. And then if you remember from over here, that omega is theta over t, so this theta over t here, we can replace with omega. So there's different forms to find linear speed, and the one you use is just based on what the problem is asking. This is an example just showing you kind of a real life situation of linear and angular speeds. It says a human joint can be flexed. The fastest is the wrist, says which can rotate through 90 degrees or pi over 2 radians. Notice how they've changed that to radians in 0.05 or 0.045 seconds while holding a tennis racket. It says the angular speed of the human wrist swinging a tennis racket is this formula. So we can substitute in our angle pi over 2 over time, and that gives us an angular speed of 35 radians per second. So this slide, we're just going to use the formula. So we're going to use omega equals theta over t in order to find, depending on what they give us, what's missing. In this case, we have omega, we have time, so we're looking for theta. So if you take your formula, which is omega equals theta over t, solve for theta, we get omega times t. So we can substitute to find theta. We can substitute in pi over 4 radian per minute, and then we can multiply that by 5 minutes. Now it's important that you think about units here, because you're going to cancel units. In this case, my units are going to cancel out for the minutes. So our angle will be 5 pi over 4 radians. In the second example, we need to find the linear speed, which is v, and they give us r omega, so we're just going to substitute in 8 centimeters for the radius times 9 pi over 5 radian per second. Now the radian is just indicating that that's the angle, so we're going to simplify this, which will give us 8 times 9 will be 72 pi over 5, and our units will be centimeters per second. The last example has multiple parts. Suppose that P is on a circle with a radius of 15. So I'm just going to kind of draw this lovely circle here, and I'm going to sketch the radius, which is 15. Keep in mind it's going to be 15 inches. And it says P is somewhere on that circle. So it says that ray OP, so this is OP, this ray right here, is rotating around the circle with an angular speed radian per second. So let's identify what we have. I just realized that this left off, I thought we were missing something. So angular speed, if you will, I think your sheet will have it. So it should be pi over 12 radian per second. It says find the angle generated by P in 10 seconds. All right, so we're looking for the angle. Remember, your angle has to be in radians. So we have information. We know R is 15 inches. We know omega equals pi over 12 radian a second. And we have T is 10 seconds. So to find the angle, our best option here with the information that they've given us is going to be the formula omega equals theta over T. And we can solve, since we need to know theta, we can solve for theta and get the formula omega times T. So let's do some substituting. Theta will equal pi over 12 radian a second times 10 seconds. Seconds cancel. That's going to give us 10 pi over 12. And we can reduce 10 over 12 to 5 over 6. So that's 5 pi over 6 radians. So theta is 5 pi over 6 radians every 10 seconds. Find the distance traveled by P. Now remember, distance is from the previous section, 3.2. That formula is S equals R theta. Remember, S is the arc length. R is the radius, theta is your angle. So we can substitute the radius, which is 15 inches, and then we can substitute theta now, which we found in the previous lesson, which is 5 pi over 6 radians. That will give us, when we reduce it, is going to be 25 pi over 2, which is approximately, if you kind of wanted to know what that distance was, that would be in decimal form 39.3 inches, which is how far it's gone around the circle. The last part here is find the linear speed of P. So here we're wanting V, which is the velocity. Now we can use several of the formulas. The easiest one here is going to be V equals R times omega. To me, that's the easiest of the formulas to use because it's just multiplication. So to find V, we're going to substitute in 15 inches times omega, which is pi over 12 radian per second. Here we will get 15 pi over 12 inch per second. 15 over 12 will reduce. That will be 5 pi over 4 inches per second, which is the speed of that angle around. If you have questions, please let me know. If not, I will see you in class next time.